Bismillahirrahmanirrahim. This is a question from paper 3-1 May June 2022 and question number 7. Topic is complex number. In this part, we need to write the complex number into the form of x plus iota y. So you can see that in numerator and denominator, we have the complex number. Whenever we are dealing with the complex number, we always try to write our final answer into the form of real plus imaginary part. Imaginary part is basically the coefficient of iota. Here we have the complex number in numerator and denominator. We try to convert the complex number which is in the denominator into the real part. And how do we do it? So we are multiplying with the conjugate of the denominator, multiplying and dividing. In numerator, it will multiply with the 1 minus 2 iota, and denominator will also multiply with this. In the denominator, we have the type of the formula that is a square minus b square. So we can directly write it the real part square and the other is imaginary part square with iota. So u would be equal to minus 2 under root 2 iota. As iota square is equal to minus 1, so we replace iota square in the step, and here are the iota square. So this term would become equal to, and iota square will be replaced with minus 1. Under root 2 is the real part, and this becomes also the real part. And then I'll take minus iota common, which is 2 under root 2 minus a under root 2, and in the denominator I have 1 plus 4. If I take under root 2 common, so it is 1 minus 2 a, and here what can I take common? Under root 2, and iota is already outside. So this is the step written in the form of x plus iota y, the real part and the imaginary part. Okay, so in this next part, value of a is equal to 3. And we need to put this value of a into the simplified form, which we have done in part number 1. So let me take this value. When we take a is equal to 3, u would be equal to 3 to the 6, and under root 2 is equal to minus 5 over 5 minus iota under root 2, and 2 minus 3, 2 minus 3. 2 minus 3 is minus 1. Okay, wait, let me check in the previous part. So when I take minus common, it is, there would be plus sign. Sorry, let me make the correction. It is 2 plus a, and this is 2 plus a. And when you take the value of a, it is 5 over 5. So u is equal to minus this and minus under root 2 iota. Okay, and we need to convert into the form of r e iota theta. R is the length of the complex number, which is called the modulus, and e iota theta can be expressed in the form of cos of theta plus iota sine theta. It means that r e iota theta is the modulus argument form. Now you need to convert this complex number into modulus argument form. If you take the modulus of u, so this would be the value of r, minus under root 2 square plus minus under root 2 square. It is 2 plus 2 and 4, the square root of 4 is equal to 2. If we are going for argument of the complex number, which is normally represented with theta, and theta is equal to tan inverse of imaginary part over real part. Let's substitute the values. Imaginary part is minus under root 2, and this is minus under root 2. In simple mathematics, when you cancel the negative sign and under root 2, so you'll get 1. Then theta will give you this answer, pi by 4. We need to verify this pi by 4 with the complex number. And how do we do it? Let's draw the complex plane as the real part. Just look at the question. Real part is with minus sign, and imaginary part is also with minus sign. Then we take the line on the negative real axis and negative imaginary axis. So these are the lines. So our complex number would lie in this quadrant. Okay. According to calculator, our answer was pi by 4. So when we extend this line on the other side, then we'll be able to find the basic angle which would lie in the third quadrant. It is pi by 4. Argument of any complex number would be greater than minus pi but less or equal to pi. It means if you take a round in anti-clockwise direction, then you'll stop at the angle of pi. To reach the angle in the third quadrant, you have to take a round in clockwise direction, and when you subtract pi by 4 from the pi, it is 3 pi by 4. I'm putting negative sign due to the clockwise direction. This implies that argument of u, which is theta, theta would be taken as minus 3 by 4. U as modulus argument form with the value of r and the value of theta, which is equal to minus 3 pi by 4 plus iota sine of minus 3 pi by 4. Finally, we convert our expression e power iota minus 3 pi by 4. So this is what we need to find. This is of the form of e power iota theta. In next part, we need to, using the answer of part B, we'll find the square root of u. Giving your answer in the form of r e iota theta, where r is positive and theta is live, giving the exact value of r and theta. So this is what we are going to do in the next step. Okay, from B part, we have found R is 2 e power minus 3 pi by 4 iota. If we write this expression into the form of 3 pi by 4 plus iota sine of minus 3 pi by 4. To find the root of any complex number, we use this formula. Uk is equal to r power 1 over n and cos of theta plus 2k pi over n plus iota sine of theta plus 2k pi over n. This is the formula to find the nth root equation. N stands for the root value, like square root. So you take n is equal to 2. If it is cube root, you replace n with the value of 3. If it is fourth root, then replace n with the value of 4. As we are finding the square root, then what do? We replace n is equal to 2. This implies that uk is equal to r was 2. R is equal to, this is the root term, and this is cos of theta plus 2k pi over 2 and plus iota sine of theta and plus 2k pi over 2. We have the value of r2. We have found r is equal to 2, theta is equal to minus 3 pi by 4. This implies that uk is equal to the first square root of the complex number. We take value of k is equal to 0, and this will give us a simple, this is minus 3 pi by 4, and in the denominator will have 2, and when you replace k with the value of 0, then this term becomes 0. Okay, so you're left with this one. This is the one answer. When you take k is equal to 1, we simply replaced value of k with 1. Okay. The next step is we need little simplification. And when you convert this into the form of e power r e power iota theta, then iota value of theta is equal to 5 pi by 8. So these are the exact answers of this complex number. Thank you very much and see you in the next video.